Hello students, now we are going to learn about the cyclic codes. Cyclic codes form a subclass of linear block codes. You know what is a linear block code. And there are several advantages of the cyclic code because we have got some disadvantages in the linear block code. We know that the implementation of the linear block code is relatively simple for single error correction, but it's too difficult for higher order error correction. So, in the advantages of cyclic code, the first advantage is it's very easy to encode. That is, the encoder can be realized by simply using a shift register. And the second advantage is cyclic codes possess a well-defined mathematical structure which leads to efficient decoding schemes. And these cyclic codes can be in systematic or non-systematic form. In a systematic form, first the check bits are calculated and it is appended with a message bit. So x is equal to m appended with c. Here m represents the message bits and c represents the check bits. There are two properties of the cyclic codes. First one is the linearity property and the second is cyclic property. You know what is the linearity property? So in this property, if you add any two code vectors, then the resultant vector is also a valid code word. So if x1 and x2 are two code words, then x3 is equal to x1 modulo addition of x2. And the second property is the cyclic property. So every cyclic shift of the code vector produces another code vector. Now consider an n-bit code vector as shown below, that is x is equal to xn minus 1, comma x minus 2, etc. up to x1, comma x0. Here, by shifting this vector cyclically to left, we get this xn minus 1, which is in the MSB. This will go and occupy the LSB position. Now xn minus 2 will be shifted to the MSB. So the new code word will be code word is formed, that is the code vector x dash is equal to xn minus 2, comma xn minus 3, etc. x1, x0, comma xn minus 1. So here every bit is shifted to left by one position. So previously xn minus 1 was MSB. Now after left cyclic shift, it is at the MSB position. So similarly, we can shift the bits either by 2-bit position or 3-bit position, so that you will get a new code word. Now we'll see the representation of the code words by the polynomial. See, the code words can be represented by the polynomial. For example, consider this n with the same n-bit code word. This code word can be expressed by the polynomial of degree less than or equal to n minus 1. That is, x of p is equal to xn minus 1 to p to the power n minus 1 plus xn minus 2 into p to the power n minus 2 plus etc. up to x1 into p to the power 1 plus x0. Here, x of p is a polynomial of degree n minus 1 and p is the arbitrary value of the polynomial. And the power of p represents the positions of the code word bits. That is, p to the power n minus 1 represents the MSB, p0 represents LSB, and p1, p to the power 1 represents the second bit from LSB side. Now let us see how the code vectors are generated in the non-systematic form. Like m is equal, there is a message vector m is equal to m k minus 1, comma m k minus 2, etc. to m1, comma m0. So these are the k-bit message vector. So it can be represented by the polynomial as m of p is equal to m k minus 1 into p to the power k minus 1 plus m k minus 2 into p to the power k minus 2, etc. up to m1 into p plus m0. Let x of p represents the code word polynomial. So this is represented as x of p is equal to m of p into g of p. In the linear block code, we studied that x is equal to m into g. So here, in linear block code, we use the matrix form of the matrix form, that is the generated matrix of the message vector. But here, we are just using the polynomial. So this x of p is equal to m of p into g of p. G of P is the generator polynomial of degree Q. So for an n comma k cyclic code and Q is equal to n minus k represents the number of variables as we know. So the generator polynomial G of P is given as G of P is equal to P to the power Q plus G Q minus 1 into P to the power Q minus 1. That's etc. up to G1 into P plus 1. In general, this G of P may be written as G of P is equal to 1 plus sigma I is equal to 1 to Q minus 1 Gi P to the power I plus P to the power Q, where the coefficient Gi is equal to 0 or 1. So in equation 3, here in 3, Gq minus 1, comma Gq minus 2, etc. up to G1 are the parity bits. If M1, M2, M3, etc. are the message vectors, then the corresponding code vectors can be calculated as x1 of p is equal to m1 of p into g of p. Similarly, x2 of p is equal to m2 of p into g of p. Like it goes on. So all the above code vectors x1, x2, x3 are in non-systematic form and they satisfy the cyclic property. Now let us take one example. That is the generated polynomial of a 7,4 cyclic code is g of p is equal to pq plus p plus 1. Find all the code vectors for the code in non-systematic form. So given n is equal to 7 and k is equal to 4. That means q is equal to n minus k, that is 3 checkpoints. So that will be total of 2 to the power k is equal to 2 to the power 4 is equal to 16 message vectors of 4 bits each. Now consider any message vector. Just say for example m is equal to 0, 1, 0, 1. So m is equal to m3, m2, m1, m0. That is 0, 1, 0, 1. Now just write the message polynomial m of p is equal to m3 p to the power p cube plus m2 into p square plus m1 into p plus m0. Now we know that this m3, sure, this is 0 and m2 is 1. Again m1 is 0. Then here m0, that is 1 into p to the power 0. So this is nothing but 1. So p square plus 1. Now we know what the generated polynomial which is given in the problem as pq plus g of p is equal to pq plus p plus 1. Now to obtain the non-systematic code vector, we simply multiply this m of p with g of p. So x of p is equal to, when you multiply this, you will get the answer. Just multiply in everything. Then the degree of the above polynomial is n minus 1, which is equal to 6. So the code vector corresponding to the above polynomial is x is equal to x6, x5, x4, x3, x2, x1, x0. The highest degree of the polynomial should be n minus 1. We know n is equal to 7, 7 minus 1 is 6. So it should start from x6 to x0. Now p to the power 6, the coefficient is 0. And for p to the power 5, 1. Similarly here 0, 0, 1, 1, 1. Now this is the code vector of the message vector 0, 1, 0, 1. But here when you see, message should come before the check bits. Okay. So here, but we are not having the same 0, 1, 0, 1 as a message. Instead we have 0, 1, 0, 0. So this code vector is in non-systematic form. Similarly, the other code vectors can be obtained by using the same procedure. So for all the message combinations, the 16 combinations, we have found out the code vectors. Here also we can see that last one, there is 1, 1, 1, 1. Here instead of 1, 1, 1, the other third bit 0. So the message is not in the message is altered. It's not in the unaltered form. Now, to check whether the cyclic property is satisfied, we just take the code vector x9 is equal to 1, 0, 1, 1, 0, 0. So by shifting this code vector cyclically to left side by 1 preposition, then we get this 0 will come to this LSB. So 0, 1, 1, 2, 0, 1. Now from the table, x dash is equal to x8. That is equal to 0, 1, 1, 0, 0, 1. So that's the cyclic shift of x9 produces x8. This we can understand from the table itself. Now we'll see. So the generation of code vectors in the systematic form. How to generate the code vectors in the systematic form. So in the systematic form, we'll get the same thing only. That is x is equal to mc, but the message will not be altered. If you are giving the message 0101 means, so here in the message bits 0101 will come. Okay, but we have one procedure for finding out this code vector. So the check bits form a polynomial as c of p is equal to cq minus 1 into p to the power q minus 1 plus cq minus 2 into p to the power q minus 2, etc. up to c1p plus c0. So this check bit polynomial can be found out by using this formula. So C of P is equal to remainder of P to the power Q into M of P divided by G of P. M of P is the message polynomial, G of P is the generator polynomial. Now, these are the steps for encoding systematic cyclic code. That is, first, multiply the message polynomial M of P by P to the power Q. Then divide P to the power Q into M of P by the generator polynomial. Then the remainder of the division is C of P. Now add this C of P, that is a check bit polynomial, to PQ into M of P to get this X of P. Now let us take one example problem, that is the generator polynomial of a 7,4 cyclic code is G of P is equal to PQ plus P plus 1. Find all the code vectors for the code in systematic form. Solution, first we must write what is N and K from the format of this block code. So for the cyclic code, this is order is 7,4. So n is equal to 7 and k is equal to 4. Therefore, the check bits n minus k is 3. So the total number of message vectors is equal to 2 to the power 4 is equal to 16. So consider any message vector. The same thing we'll just take 0, 1, 0, 1. Now write this m of p. There's nothing but p square plus 1. Then the given polynomial is g of p is pq plus p plus 1. Now to obtain p to the power q into m of p. Okay, q is equal to n minus k is equal to 3. So p to the power 3 into m of p. Just multiply this. P cube into p square plus 1. We'll get p to the power 5 plus p to the power 3. So whatever the order left out, just we must write it in order so that the coefficient whatever is not available, we must take it as 0. Then g of p is equal to, g of p is already given, pq plus p plus 1. Then we have to perform the division, that is p to the power q into m of p divided by g of p. Just do the division. When you do the division, we'll get the remainder. This is the remainder, p square, only the p square. So p square plus 0p plus 0. And we have to write like this. That means this is 1, 0, 0. Okay. So the coefficient of p square is 1, whereas for p, 0. And here also this is 0. So with q is equal to 3, the polynomial c of p for this equation, the c of p is equal to c2 into p square plus c1 into p plus c0. So the check bits are 1, 0, 0, 1, 0, 0. So C2, C1, C0. This is C2, C1, C0. Now the code vector x is equal to M3, M2, M1, M0, 0, 1, 0, 1. And the check bits are 1, 0, 0. So the code word is 0, 1, 0, 1, 1, 0, 0. Similarly, for the message bit 0, 0, 1, we can find out the code word in the same manner. First step is you have to find out p to the power q into m of p. Then divide this by g of p. Then we'll get the remainder p plus 1. So this remainder is a check bits. Okay. So here we have this C0, C1 and C2. C2 is 0 and C1 is P, that is the coefficient of P. That is 1 and this is 1. 0, 1, 1. Next add the remainder to P to the power Q into M of P. Just add the remainder. What is the remainder? P plus 1. Okay. G of P is this equation plus P plus 1. So x dash is 0, 0, 0, 1, then 0, 1, 1. So the message bits are followed by the checkpoint. Similarly, all the code vectors can be calculated and we can tabulate it like this. Thank you.